Hello everyone. Today we are going to discuss the paper of May-June 2025, paper 4-2. Now these are the instructions we have to follow. Let's move to question number 1. Question number 1 is that a crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 Newton inclined at 20 degree above the horizontal. The crate moves a distance of 12 meters in 8 seconds with constant speed. So what does it mean? It means that we have a straight horizontal surface and there is a crate on this and a force of 25 Newton force is applied with an angle of 20 degrees. Now what we have to do is the crate moves a distance of 12 meters in 8 seconds. So find the constant speed. So we need to find the constant speed. So for constant speed what we have to do is we know that S is equals to d by t. So the distance is here the distance is 12. So 12 divided by 8. So this will be equals to 12 divided by 8. So this will be equals to 3 by 2 or 1.5. So the speed will be equals to 1.5 meter per second. Let's move to the B part. Find the work done by the force 25 or 25 Newton. We know that for work done we have to use this formula that uh, we have to use we have to use the horizontal component, that is if we resolve it into components this will be 25 cos of 20 and this component will be 25 sine of 20. Now find the work done by the 25 Newton force. So for work done what we have to do is we have to use the distance, like W is equals to Fs. Now we have to use the horizontal component. So this will be equals to W is equals to 25 cos of 20 multiply by 12. So W is equals to, let me check this, 25 cos of 20 multiply by 12. So multiply by 12. So this will be equals to, keep one thing in your mind that the angle should be in degree mode. Here you can see that the calculator is in the radian mode. So be very careful about it and your calculator should be in the degree mode. So let me convert it into the degree mode and now let's find out the answer. So this will be 281.9. So the answer will be 281.902. As you know that it is for non-exact answers we have to write our answer in three significant figures. So this will be 282. So this will be the final answer for the B part. Let's move to the next one. Find the power at which the 25 Newton force is working. So for power what we have to do is we know that P is equals to Fv. Now the force is P is equals to Fv. Now the velocity is 1.5, as we have discussed in the first part that the velocity is 1.5 newtons. So what we have to do is we can use the velocity that is 1.5. And now for force what we have to do is we have to use the horizontal component of the force. So this will be 25 cos of 20 multiplied by 1.5. Now if you find out the answer, this will be 25 cos of 20 multiplied by 1.5. So the answer will be 35.238. P is equals to 35.238. So if we want to write it into 3SF, so this will be 35.2. This will be the final answer. Let's move to the next question, question number 2. Now in question number 2, they're saying that two particles P and Q of masses 0.2 kg and 0.1 kg respectively are free to move in a straight horizontal on a smooth horizontal plane. P is projected towards Q with the speed of 5 meters per second at the same instant. So let's write the let me write the situation over here. That here the situation is that we have two particles. So we have to use the situation, that is we have a circle P and it is particle P of mass 0.2 kg, 0.2 kg, and it is moving with the speed of 5 meters per second. Similarly, at the same instant, Q projected towards P with the speed of 2. So P is projected towards Q with speed this. At the same instant, Q is projected away from P. So it means that this particle is, let's say, Q, and its mass is 0.1 kg, and it is projected away from the particle P. So with the speed of 2 meters per second. Okay, fine. Now, when P collide with Q, the particle coalesce. Find the kinetic energy lost during the collision. Now, what we have to do is we need to use the law of conservation of momentum. So what we have to do is before collision, total momentum before collision is equals to total momentum after collision. So 0.2 into 0 into 5 plus 2 into 0.1 is equals to, now this will be 0.2 plus 0.1 into V. Now if we rearrange it, this will be, let me use it, this will be 5 multiplied by 0.2 plus 2 multiplied by 0.1 6 by 5. So 6 by 5 means 1.2. So 1.2 is equals to 0.3 V. So V will be equals to 1.2. V will be equals to 1.2. So we can say 1.2 divided by 0.3. So velocity after the collision will be 0.3. So velocity after the collision will be 4 meters per second. So this will be 4 meters per second. Now what we have to do is we have to find out the lost in kinetic energy. So for this, what we have to do, we have to find out the initial kinetic energy. Initial kinetic energy will be 1 by 2 into 0.2 into 5 square, half mv square, plus the kinetic energy of both the particles will be 0.1 into 2 square. So finally we will what will be the final answer? This will be, now this will be fraction 1 by 2 multiplied by 0.2 multiplied by 5 square plus fraction 1 by 2 multiplied by 0.1 multiplied by 2 square. So this will be equals to 27 by 10, which means 2.7. So this will be the initial kinetic energy. Now what we have to do, we have to find out the final kinetic energy. So for final kinetic energy, this will be equals to 1 by 2 mv. So mass is 0.2 plus 0.1 and v square. Now the mass velocity is 4, so 4 square. So basically this will be 1 by 2 into 0.3 into 16. So if we simplify it, this will be fraction 1 by 2 multiplied by 0.3 multiplied by 16. So this will be equals to 2.4. So we can say that the final kinetic energy is 2.4. So the loss will be what? The loss will be loss of kinetic energy. This will be equals to 2.7 initial kinetic energy minus final kinetic energy. So this will be equals to 0.3. So finally this will be the final answer. Loss of kinetic energy. This will be the final answer. I hope that the concept is clear. Let's move to question number 3. On question number 3, what we have to do is we need to question number 3. A particle of mass m kg is attached to one end of an light inextensible string of length 2.6 meters. The other end of the string is attached to a fixed point on a horizontal ceiling. The string is taut. It means, now taut means, we need to highlight the key words. Taut means that there will be a tension. The particle is held in equilibrium. Okay, equilibrium means the horizontal and vertical forces will be equal. Sum of the vertical force is equal to 0. Sum of the horizontal force is equal to 0. Now, acting on a vertical plane which is perpendicular to the ceiling and containing the string, the force act in a direction perpendicular to the string. The tension in the string and the vertical distance of P from the ceiling is 2.4. Find in either order the value of M and the value of T. Now what we have to do is we know that this distance is what? This distance is basically 2.4. We can easily find out this angle. Now this angle sine theta will be equals to, sine theta is equals to 2.4 divided by 2.6. So theta will be equals to sine inverse of 2.4 divided by 2.6. So if we try to find out the values, this will be 2.4 divided by 2.6. So this, if sine inverse will be what? Sine inverse of the answer, this will be equals to 67.38, which means 67.4 degrees. Now what we have to do is we need to find out the remaining angle, this angle. Now how we can find out the remaining angle? This will be equals to 180 minus 90 minus answer, the previous answer. So this will be equal to 22.6. Now what we have to do, we have to now resolve the forces into its component. So how we can resolve the forces into its component? Now the particle of mass, the particle of mass is now what we have to do is we need to see the tension as well. There is a tension in the rope, so we have to see that there is a tension in this string. So this force, now if we resolve it to horizontal and vertical components, so first of all we know that the system is in equilibrium, which means summation of fx summation of fy is equals to 0, and the vertical components for the t will be t sine of 67.4. This will be this, and then we have 35. For 35, what will be? So for 35, this will be plus 35 sine of 22.6, sine of 22.6, and then we know that this particle is going downward. So this particle is going downward. We know that the vertical component is positive here. The vertical component is positive here, and this one is the vertical component of the weight will be negative. So we know that this is the mass is 10. So if the mass is 10, it means that the weight will be mg, and g is 10, so 10m. So we can write it as minus 10m is equals to 0. Now if we further simplify it, this will be basically t sine of 67.4 is equals to 10m minus 35 sine of 22.6. This will be the equation 1. Now what we have to do, we have to see the other way. The other one, that is summation of fx should be equals to 0. Now for summation of fx, we have to see the horizontal components. So horizontal component of 35 Newton force will be 35 cos of 22.6, 35 cos of 22.6 minus, what about T force? Minus T cos of T cos of 67.4 is equals to 0. Now from here we can easily find out the value of t. So t will be equals to, like, t cos of 67.4 is equals to 35 cos of 22.6, and then t will be equals to 35 cos of 22.6 divided by cos of 67.4. Now from here we can easily write down the value of t. So this will be equals to 35 cos of 22.6 divided by cos of 67.4. So the answer will be 80.082. So basically this will be 80.0. Now just put the value of t over here. This one is your first answer. Now just put the value of t over here. This will be 80.0 sine of 67.4 minus 35 sine of, basically this will be plus now, sine of 22.6 is equals to m whole divided by 10. So m will be equals to, we can use the calculator and we can get the final answer. So m will be equals to 80.08 multiplied by sine of 67 sine of 67.4 plus 35 sine of 22.6 bracket close divided by 10. So this will be equals to 9.107. 9.107. So 9.107. This will be the final answer. If you want to write it into 3, is there any instructions over here? No, there is no instruction. So what we have to do is, this will be the final answer, that m will be equals to 9.107 means 0, this will be 0, 1. This will be the final answer. Let's move to question number 4. A car is traveling along a straight horizontal road. The car passes through a point A on the road traveling to a speed of 15 meters per second and then accelerates uniformly at 0.4 meters per second for 30 seconds. Now, it means that it's on the road traveling at a speed of 15 meters per second and then accelerates uniformly at 0.4 meters for 30 seconds. Now, what does it mean? It means that we know that the acceleration, okay, for the first 30 seconds, as we know that the speed is 15, we need to find out the velocity for the first 30 seconds. So for the first 30 seconds, we know that if we want to find out the gradient, we will find out, basically we are finding out the acceleration. So acceleration is equals to, we need to find out, let's say this is the point for first 30 seconds. We know that here the coordinates are 0 and 1. Let me write it over here, that 0 and 15, and the other coordinates are 30 and v. Now what we have to do is, we can write it as v minus 15, y2 minus y1 divided by x2 minus x1. So we know the acceleration is 0.4. So we can write it as 0.4 is equals to v minus 15 divided by 30. And if we rearrange it simply, this will be 0.4 into 30 plus 15 is equals to v. So if we use a calculator, this will be 0.4, be very careful about calculation, 0.4 into 30 plus 15 plus 15. So this will be equals to 27. It means here the point will be 27. Now let's move to the next part. The car then moves at constant speed of 3t seconds. For 3t seconds means that this will be the point. We can say it as 30 plus 3t, where t is less than 30. The car then decelerates uniformly at 0.2 meters per second. Okay, here and then uniformly at uh, uniformly at 0.2 meters per second. So it means that it will take it will take the car then DC uniformly at 0.2 and after further t second passes through a point B on the road. Okay, so it means that this point will be 30 plus 30 plus 3t plus t, because they are saying that for the t seconds. Now this will be the graph. Basically, sketch a velocity time graph for the motion of the car between A and B. Yes, we did it. Let's move to the next one. The distance from A to B is this. Find the value of t. Now, how you can find out the value of t? You know that the total distance is 2750. Now, the how we can find out the value of t? So we know that the final velocity will be what? Final velocity. This will be equals to what? Final velocity will be this point. At this point, final velocity will be what? This will be, you can see that this will be, okay, then deceleration, or basically final acceleration, we can say that this will be 0.2. So for 0.2, we need to find out what? We need to find out, we can write it as v minus, because we don't know where it stops. Let me clarify this thing that we are not sure about where it stops. So actually let me clear it, that this one is basically this point. We don't know the value of v over here, that what will be the final velocity. So for final velocity, we know that deceleration is, for final velocity, we know that the acceleration is minus 0.2, and if we try to find out, we use the same process. If we will try to find out, like the coordinates here are uh, 30 plus 3t, and here the coordinates are, x coordinate is this, and the y coordinate will be, y coordinate will be 27. Here the x coordinate is 30 plus 4t and the y coordinate will be v. Now v minus 27 divided by what? Divided by 30 plus 4t minus minus 30 minus 3t. So this will be equals to t. So basically the final velocity will be minus 0.2 is equals to v minus 27 divided by t, and from that here we can say that v will be equals to minus 0.2 t plus 27 is equals to v. So this will be the first equation. Now let's see that the total distance is 2750. Now how we can find out the total distance for the first part? For the first part, this one is a trapezium. So for trapezium, what we have to do is, we know that the total distance is equals to 1 by 2 sum of the parallel sides. So sum of the parallel sides means 15 plus 27, 15 plus 27 into 30, because 30 is this, we will consider it as a height. This side is the height and these two sides are the parallel sides. Now this one, for the first part we did it. For the second one we know that this one is a uh, this one is a rectangular shape, so we can say that this will be the distance between these two. The distance between these two will be this minus this, so this will be 3t, and this portion will be 27. 3t and 27, so the area for this will be 3t multiplied by 27 plus, for the last part again we have a trapezium. So for trapezium what we have to do is this side will be this will be this whole length is basically the vertical distance will be, velocity was what, the value of velocity was, yes, this one is v, this length is v, and this whole length is 27, sum of the parallel sides into, now this length will be t again. So what we have to do is sum of the parallel sides means 0.2t plus 27 plus 27 again into t. For the last part, let me explain it again, that for the last part what we have to do, for this portion what we have to do, we need to find out the area of this. We know that for this portion the area will be sum of the parallel sides, and 27 plus v, and I just put the value of v over here. There is a small mistake that I should add sign minus over here. If you simplify it, you will get the final value of v. So the final value, okay, the thing is that here you should write 2750, 2750, and this will be 1 by 2 into 15 plus 26, 32, 42, 42 into 30 plus 54, 27 into 3, 27 into 3, this will be 81, 81t plus 1 by 2 into 54 minus 0.2t into t. Now if you simplify it, if you know that the only unknown variable here is t, and if you will simplify it on calculator, you will get t is equals to 20. So this will be the final answer. I hope that the concept is clear. Let's move to the next question, next part, that is C part. Find the total distance from A to C, but there is a slight change over here, that the car continues its journey from B, decelerating uniformly at 0.5 meters per second square until it comes to rest at a point C on the car. Find the total distance of the car. So now we need to find out the total distance of the car from A to C. But before this, what we have to do is, at B the velocity is, let me write it over here. By the way, this point is B. This point is B. This point is B, as mentioned in the question, that this point is basically the B point. Now, the velocity at B is equals to, we know that the equation was v is equals to minus 0.2 t plus 27. Now the value of v was 20, so this will be minus 0.2 into 20 plus 27. So minus 0.2 multiplied by 20 plus 27. So this will be equals to 23. So at B, the velocity is 23. Now what we have to do, we know that the initial velocity is 23. We are just trying to use the last portion over here. Let me highlight it with some other color, that is, let's say green. We need to find out, we are just discussing this part, and for this part we know that for this part what we have to do is we need to see, yes, initial velocity is 23 and acceleration is, it is given that is minus 0.5, minus 0.5, and then final velocity is 0 because it reaches to the rest, and we know that we have to find out the distance. So what we have to do, we can use this equation v square is equals to u square minus 2as, and if we rearrange it, 2as is equals to u square minus v square, and it means that s is equals to u square minus v square whole divided by 2a. So finally the distance will be u is 23 square minus 0 square divided by 2 into minus 0.5. So here we will get what? We will get, just use the calculator, that 23 square fraction, 23 square, 23 square divided by 2 into minus 0.5, minus 0.5. Okay, so this will be equals to basically 529. So distance cannot be -1, so 529 meters. This will not be the final answer. This is basically the distance from B to C. Now what we have to do, we know the distance from A to B is, it was given in the question that it was 2750. 2750. So the total distance will be equals to 2750 plus 529. So the total distance will be equals to, this will be equals to what? Just add plus 529, 2750 plus 529. So this will be equals to 3279 meters. 3279 meters. So this will be the final answer. I hope that the concept is clear. Let's move to the next one, next part. Question number 5. Question number 5, what we have to do is, this one is the question. We need to read the question carefully, and then what we can do is we need to simplify it with portion wise, like we need to find the tension in the string for each of the case. So let me write it like, let's say the weight over here is 50 and the tension over here is T1. Similarly, the tension in the string will remain same, so this will be T1 and this will be T2. And then for this part, this will be T2 because tension will remain same in the for the same string. And we need to resolve this component into this force into its component, the parallel to the surface and perpendicular to the surface. The parallel to the surface, because this one is weight, we need to resolve it into the parallel to the surface and the perpendicular to the surface, and this angle is of 30. So we need to see all the forces one by one, and then we will try to find out the values. Like first of all, we can see that the acceleration is what? Downward with the acceleration is 2.4 meters. 2.4 meters per second. This one is the acceleration vertically downward. So what we have to do for particle C, let's start from the particle C. For particle C, what we have to do is we need to use the vertical sum of the vertical component. The summation of fx summation of fy is equals to ma. We need to apply it. So this will be equals to T1 minus 50 is equals to mass of C was 5. So 5 into acceleration is going downward. So 5 into minus 0 minus 2. So 5 into minus 2. So from here we can easily find out the value of t. The value of t here will be T1 will be 50 minus 5 into 2. So this will be equals T1 will be equals to 40. Now let's see the particle B. For particle B, we know that we have to apply summation of fx is equals to ma because acceleration is in the horizontal mode. So this will be equals to T1 minus T2. T1 minus T2 is equals to ma. So we know that acceleration is 2. Here this will be positive 2 because it is going towards the right side. And mass is 4 for particle B. So this will be 4 here. Now T2 will be equals to what? T2 will be equals to T1 minus 8, which means T2 is equals to 40 minus 8, which means this will be equals to 32. I hope that the concept is clear. Now let's see the third one. For the third one, for a particle, we have to use the vertical component as well as the horizontal component. So for this, what we can do is, okay, we need to see that is it okay, and the horizontal plane, greatest slope of incline. Okay, what smooth horizontal plane? Just I was searching for this word that whether we have to ignore fraction or not. So there is a smooth horizontal plane. So for that is why we will ignore the fractions. So we have to see that for horizontal components this will be, now we are discussing the particle A. So for horizontally parallel to the surface will be basically parallel to the surface is equals to MA. So parallel forces will be T2 minus the component of the weight W sine of 30. W sine of 30 means the weight for this one is 30. So 30 sine of 30. 30 sine of 30 is equals to 3 into 2. So here we can see that T2 will be tension in each string. So we need to find out T1 and T2. I think that is it. We need to find out the tension in each of the string. That is it. I think for this part, I think that's enough. We just need to find out tension. From here again, we are just verifying that the tension in the second string is this. We can use the components in the next part. Okay, the coefficient of the friction between A and the inclined plane. So the coefficient of for the coefficient of friction, we will use this concept that friction is equals to mu r. Now r will be equals to what? R will be equals to what? R will be equals to basically this force, this reaction force will be called R. This one will be R. So R will be equals to W sine of 30. R will be equals to R will be equals to W sine of 30 because it will be equals to the vertical component. So R is equals to 30 sine of 30. So 30 sine of 30 will be what? 30 multiplied by sine of 30. This will be equals to 15. So R is equals to 15. Let me see the vertical components as well. So R is equals to W sine of, yes, W sine of 30. So 15 square root, this will be, okay, R will be equals to W cos of 30, yes, because this one is equals to the parallel component, the perpendicular component. Why it is this? Let me explain it to you. We know that R minus W cos of 30 is equals to 0. Basically, we are applying summation of Fy is equals to 0 for the particle A. Why we are taking it as 0? Because we are using this concept that MA. Now vertically, for example, the perpendicular direct in the perpendicular direction, the acceleration is 0. In the perpendicular direction, the acceleration is 0. That is why we are ignoring it. That is why we are taking acceleration as 0. So this will be equals to acceleration will be equals to 0. So R will be equals to 30 cos of 30. So 30 cos of 30 means 30 cos of 30. So this will be equals to 15 square root of 3. 15 square root of 3. So what we have to do is, we know that R will be for the last one, summation of Fx is equals to ma. So for particle A, this will be T2 minus W sine of 30. So T2 minus 30 sine of 30 is equals to MA. Mass is 3. So 3A. So 3. Okay, there is another force, that is the frictional force, minus Fr is equals to 3 into A. Acceleration is 2. We know that the acceleration is 2. So we know the value of T2. So T2 is 32. So this will be 32 minus 30 sine of 30 minus 6 is equals to mu r. Mu r. So if we rearrange it again, so the coefficient of friction will be equals to 32 minus 30 sine of 30 minus 6 whole divided by 15 square root of 3. So what we can do is, we can use the fraction that 32 minus 30 sine of 30 minus 6 divided by 15 square root of 3. So this will be equals to what? This will be equals to 0.423. If we correct it to 3SF, so mu will be equal to 0.423. So this will be the final answer. I hope that the concept is clear. Let's move to the last part, C part. When the system has been in the motion for 1.5 seconds, the string attached to A breaks. Find the total distance that A travels up the plane from the instant the system is released from the rest to the instant that A comes to instantaneously at rest. So from here we can see that U is equals to 0, A is equals to 2, and T is equals to 1.5, and we need to find out the distance. So how we can find out the total distance? So this distance will be S is equals to ut ut plus half at square. So S is equals to 0 into 1.5 plus 1.2 into 2 into 1.5 square. So this will be equals to 0. This will be equals to, if we simplify directly on calculator, we will get 0 plus 1.5 square. We can cancel out these two. So 1.5 square will be what? 1.5 square. This will be equals to 2.25. So the distance will be 2.25 meters. Now what we can do is the string breaks. So string breaks means that we can find, we know that what will be the final velocity. So the final velocity will be, when the string breaks, the final velocity will be v is equals to u plus at, u plus at. So the final velocity will be 2 into time is 1.5, so v will be equals to 3 when string breaks. Okay, now what we have to do is we need to see the conditions again, that this will be, this portion will be like when the string breaks, basically this one is the inclined position, and we know that the reactive force is, this portion is 15, this portion is 1.5. So we can say that, let me see the conditions, that as it covers the distance till here, it will be, it, let's say it covers the distance of 2.25 and string breaks again. So it will be moving downward. So basically this distance is, let me draw it over here, that basically this distance is 2.25, and when the string breaks, the distance is 2.5 meter, as it is going with 3 meters per second. Now this will be equals to, now how we can find out the acceleration? For acceleration, actually the mass is 3, yes, the mass is 3a, and this will be minus 15 minus 11, minus 15 minus 11. How we can find out the acceleration? This will be 3a, so a will be equals to minus 26 by 3. So a is equal to minus 2. So now let's conclude it. So we know that the initial velocity is 3, acceleration is minus 26 by 3, final velocity is 0, and we need to find out the distance. So s is equals to s not s is equals to, we can use the formula for s. So this will be v square is equals to u square minus 2as. So v is 0, so 0 square is equals to 3 square minus 2 into this s. So if we rearrange it, this will be 2, this will be 0 is equals to 9 plus 52, yes, 52 by 3s. So s is equals to, if we simplify it, s will be equals to 2.7692. So 2.77 will be the final answer for this. I hope that the concept is clear. Let's move to question number 6. Now in question number 6, the particle moves in a straight line. Find the maximum velocity. Now we know that when we have maximum velocity, it means dv by dt is equal to 0. So find the maximum velocity of p in the interval this. So we need to find out dv by dt. So dv by dt will be equals to what? 3 by 2 into 2t plus 1. 3 by 2 minus 1 minus 2 is 1 by 2 multiplied by 2 minus 4t. Now when it is 0, this will be 3 into 2t plus 1 whole power 1 by 2 minus 4t. Now what we can do further, we can just write it as 3 power 3 into 2t plus 1 whole power 1 by 2 is equals to 4t. Now take square on both sides, we will get take square on both sides, we will get 9 into 2t plus 1 is equals to 16t square. 16t square. So this will be equals to, we can rearrange it, and 2t plus 1 is equals to 16t square divided by 9, and if we rearrange it, this will be 18t plus 9 is equals to 16t square. So 16t square minus 18t minus 9 is equals to 0. Now we can use the calculator to simplify it, although we have to show our working. So this mod 5 3 16 16 minus 18 minus 9. So t will be equals to 3 by 2 means 1.5, and t will be equals to minus 3 by 8. So we will ignore the negative sign and we will take this one because time cannot be negative. So what we have to do, we can use the equation of motion, that is v is equals to 2 into t means 1.5 into, okay, not equations of motion, we need to use, we can use the equation of velocity. It was given to us here that v is equals to 2t, v is equals to 2t plus 1 whole power 3 by 2. So let me use the values again, that v is equals to 2 into t is 1.5 uh, plus 1 whole power 3 by 2, 3 by 2 minus 2 into t square means 1.5 square. So we will get v is equals to what? We can use the calculator to get the final answer. This will be, we can write it as bracket 2 into 1.5 plus 1 bracket close whole power 3 by 2, 3 by 2 minus 2 into 1.5, 2 into 1.5 square. So this will be equals to 7 by 2, which means 3.5. So this will be the final answer. I hope that the concept is clear. Let's move to the B part. It is given that in the interval this, the velocity of p is always positive. Find the distance of p from A at the instance when p is moving in the maximum velocity. So we can see that the equation for velocity was 2t plus 1 whole power 3 by 2 minus 2t square. Let me confirm it again. Minus 2t square. Yes, minus 2t plus 1 3 by 2. So we can, this one is the equation for velocity. Now let's find out the distance. So for distance we need to integrate it. So if we integrate it, this will be 2t plus 1 whole power 5 by 2 divided by 5 by 2 into 2 minus 2t cube divided by 3. Now we just need to put the limits from 0 to 1.5. When p is moving with the maximum velocity, we know that when the velocity is maximum, at that point time is 1.5. We just need to put the values of upper limit and lower limit. So this will be, d will be equals to, upper limit will be 2 into 1.5 plus 1 whole power 5 by 2 divided by 5 plus 2 into 1.5 whole cube divided by 3. When you put 0, this whole portion, the second portion, will not be 0. Do not do it directly. Just put 0 over here. You will get 2 into 0 plus 1 divided by 5, and then this portion will be 0. So overall the answer for the second half will be 1 by 5. This will be 1 by 5. Now what we need to do is we need to calculate it. We need to find out from here the first part using the calculator, that fraction brackets 2 into 1.5, 2 into 1.5 bracket close plus 1 bracket whole power 5 by 2, 5 by 2, and then 5 by 2 whole divided by 5 plus fraction 2 into bracket 1.5 whole cube divided by 3 and bracket close. Let me see that I have started the bracket or not. No, it's not, so it is not required to end the bracket from here. So this will be equals to, yes, there is a syntax error. So what we have to do, we have to start the bracket from here. This will be 173 by 2 minus fraction 1 by 5. So this will be equals to 8.45. 8.45. Okay, let me do it again. That fraction 2 into 1.5 plus 1. We need to set the brackets here. Whole power plus 1 whole power, what, whole power 5 by 2, 5 by 2 whole divided by 5 plus fraction 2 into 1.5 whole power 3 divided by 3. So this will be equals to 170. Okay, this thing is minus, this one is minus. I have to be very careful about it. This should be minus. So if you use minus over here, this will be, the final answer will be 83 by 20 minus 1.5. Minus 1.5, and if you simplify it, this will be equals to 3.95. So this will be the final answer.